Welcome to the Deep Dive. Today, we're zeroing in on a really crucial aspect of designing microservices, something that, consistently comes up for anyone preparing for senior software engineer interviews.
Yeah.
The role of schemas.
Yeah.
Specifically, should our microservices be using explicit schemas? It's a question that sparks a lot of debate and has significant implications for how we build and maintain our systems.
It's absolutely central. When you're architecting at a microservices level, you're essentially building a distributed system, and the way those individual services communicate is paramount. Defining those communication boundaries clearly, especially the data flowing across them, that's really a cornerstone of reliability.
Exactly. And when we talk about schemas, for many of us, that probably brings to mind specific tech depending on the data format. If you're in the XML world, you're likely thinking XML schema definition, XSD.
Right.
And if JSON is your lingua franca, then JSON schema comes to mind. It's also worth remembering that certain architectural styles and technologies almost force the issue, don't they? Like think SOP with WSDL.
Oh, yeah, or gRPC with protocol buffers.
Right, gRPC too.
Those technologies inherently weave the schema right into the fabric of how services interact. So in those cases, the conversation shifts, really. It's less whether to have a schema and more how to design and manage it well. The more nuanced and, frankly, often more debated scenarios pop up when you're using tech where schemas are, well, optional.
And that's precisely where we're going to focus our deep dive today. Our goal is to really dissect the advantages of using explicit schemas versus maybe the arguments for a more laissez-faire approach in microservice communication.
Yeah, the schemaless idea.
Exactly. We want to understand what truly contributes to building systems that are not only robust, but also easy to maintain and evolve, aspects that are, absolutely critical for anyone aiming for a senior engineering role.
Yeah.
So let's jump right in. What makes a strong case for using explicit schemas?
Well, the most immediate benefit is just the sheer clarity they provide. An explicit schema acts as this undeniable, well-defined representation of what a microservice exposes at its endpoint, both what requests it expects and the structure of the responses it'll send back. This clarity is a huge win for the teams actually building the service, gives them a concrete contract. But it's equally, maybe even more, valuable for teams that need to consume that service.
Right. They get a reliable map.
Exactly. A reliable, machine-readable document showing precisely how to interact.
Yeah, it makes perfect sense. It's like having a very detailed blueprint for how these different system parts should talk to each other. You know exactly what the inputs and outputs should look like. And while you mentioned it doesn't entirely replace documentation, it must significantly streamline it, surely.
Yeah.
Less need for long essays explaining data structures.
Precisely. You still need narrative docs for the higher level stuff, the business logic, intended use cases, the why behind the service.
Sure, the context.
But the schema nails down the fundamental what of the data exchange.
No.
And it's a contract you can validate programmatically, which gives you a level of certainty that, human readable docs alone just can't match.
Okay, so enhanced clarity for both producer and consumer, big plus. What's another key reason you'd advocate for explicit schemas? You touched on them helping prevent accidental breakages. Let's dig into that.
Yeah, this is where the real power shows up, especially in dynamic microservice environments where things are changing all the time.
Right, independent deployments.
Exactly. When different services are updated and deployed independently, the risk of one service's change just inadvertently breaking a consumer is always there. Explicit schemas act as a crucial safeguard against these kinds of regressions, and to really get how it helps to think about the different types of breakages.
Right, we talked about structural versus semantic. For anyone listening who might be prepping for those technical interviews, understanding this difference is really key. Can you walk us through structural breakages first?
Sure. A structural breakage happens when the actual format or the shape of the data being exchanged gets altered in a way that makes an existing consumer incompatible. So, imagine an API endpoint used to include a field, let's say userid. If a later version of that service just removes this field, any consumer app that was expecting it, well, it's likely going to run into errors.
Yeah, crash and burn probably.
Or similarly, if a new field is added and marked as mandatory in the request, older clients that don't know to send it will suddenly start getting errors back.
So it's a fundamental change in the data's, anatomy. You gave a good example earlier about an add method. Originally took two integers, then changed to take just one. That's pretty clear-cut structural.
Exactly. Those kinds of changes, adding required parameters, removing existing ones, changing data types, they directly mess with the expected structure. Generally, these structural breaks are somewhat easier to spot
I like that.
because they often lead to immediate, obvious failures, exceptions during deserialization, validation errors. The consuming app usually complains loudly right away.
Okay, clear picture on structural. Now, what about semantic breakages? You mentioned these can be a bit more insidious.
They certainly can be. A semantic breakage is when the structure of the communication stays the same, the fields are there, types haven't changed, but the meaning or the underlying behavior associated with that communication has been altered. Altered in a way that violates the consumer's assumptions or, worse, its business logic.
Okay, let's go back to that add method example for a semantic change. How would that work?
Right, so let's say your add method still takes two integer inputs, still returns a single integer output, structurally looks fine, right?
Yep, same shape.
But what if the initial implementation actually added the numbers, but a later update changed the logic so now it multiplies them?
Ooh.
A consumer sending two numbers, getting one back. Structurally it works, no technical errors, probably no crash, but the meaning of that result is totally different.
Right, and that could cause silent but, like, critical errors downstream.
Absolutely. Could impact business outcomes in really subtle, hard-to-detect ways. You might not notice until month-end reporting is completely wrong or something equally bad.
Ah, I see the distinction clearly now. The code might not obviously break, but the results are just wrong. Much harder to debug.
Precisely. And this really highlights a key limitation of schemas, actually. While they're amazing at describing and enforcing data structure, they typically don't, and often can't, capture the full semantics or the intended behavior.
Okay.
Detecting semantic breaks needs more sophisticated stuff, mostly thorough testing integration tests, contract tests that verify behavior, and just a deep understanding of the business logic on both sides.
Right. So schemas are powerful on the structural front. How exactly did they help us proactively catch those kinds of breaks?
By using schema versioning and automated validation, when you change a microservice endpoint structurally, you also update its schema. Then, by comparing the new schema version with the old one.
Ah, like a diff.
Exactly, like a diff for your API contract. You can automatically identify if any structural changes happen. Field removed. New required field added. Data type changed incompatibly. This automated comparison lets you flag potential breaking changes before you deploy.
That sounds hugely valuable, like an automated early warning system for structural problems.
It is. It gives you a chance to warn consumers or maybe build in backward compatibility before anything actually breaks in production.
You drew an analogy earlier to static versus dynamic typing in programming languages, which I found really helpful. Could you maybe walk through that again, useful for interviews?
Absolutely. Think about it. In a statically typed language like Java or C#, you declare variable types up front. The compiler checks types at compile time.
Right, before you run anything.
Yeah. If you try, say, a string operation on an integer, the compiler catches it. Boom. Error. Before runtime. This frees up your testing effort to focus more on the actual logic, not basic type errors.
Okay, makes sense. And how does that relate back to microservice schemas?
Explicit schemas act very similarly to static typing, but for your data exchange between services. They explicitly define the structure and types. By implementing schema validation checking data against the schema, you catch structural mismatches early.
So like at build time or in CI?
Ideally, yes. Or even just during development. If a consumer sends a field the producer doesn't expect anymore, or the producer changes a type a consumer relies on, schema validation flags it immediately.
Okay.
This proactive check really cuts down the burden on integration tests, letting them focus more on verifying business logic and catching those sneakier semantic breaks we talked about.
Got it. The parallel is clear. Shift error detection earlier leads to more robust systems.
Yeah.
Now, you also made a compelling point that even with so-called schemaless APIs, consumers still have expectations, right? An implicit schema exists.
That's a really fundamental point, I think. Even if you don't formally define a schema, any code-consuming data from an API is built on assumptions about what that data looks like.
Sure. The developer looked at some example responses.
Exactly. They looked at examples, maybe guessed a bit, and wrote code based on that which fields are present, their types, the overall structure. That consumer code embodies an implicit schema.
Hidden inside the implementation details.
Right. And the argument for explicit schemas is simply that it's far better to make those expectations clear, formal, and machine-readable for everyone involved. Reduces ambiguity, less risk of misunderstanding, provides a solid foundation.
So you're basically saying a schema exists whether we write it down or not. It's just a question of whether it's open and enforceable or hidden and potentially brittle.
Precisely. Making it explicit offers huge advantages. Clearer team communication, better maintainability, and a big reduction in those unexpected structural breaks when services evolve.
Okay, now let's tackle a common pushback. The argument that schemas mean more overhead, more work to define, maintain, maybe not enough value to justify it. What's your take?
That's a fair point, often comes up. I think it often stems from a couple of things. First, maybe a lack of imagination or just experience about how effectively schemas can be leveraged, especially with good tooling.
Right, if the tooling is painful.
If it's easy to define, evolve, validate, compare schemas, the overhead feels much smaller. Automation is key here. Schema validation comparison. That streamlines things massively.
And the second factor.
Sometimes it's just not having felt the pain of a structural break in production yet. When services suddenly can't talk, that causes real disruption. The upfront effort for schemas often seems tiny compared to debugging a production outage caused by an unexpected API change.
So the value isn't always obvious until you've been burned by a breaking change in a dependency.
Kind of, yeah. It's like insurance. You don't see the daily benefit, but it's crucial protection for when things go wrong. That explicit contract saves so much time, effort, and potential disruption down the line by stopping those integration failures before they happen.
Okay, so summing up this core part, implementing explicit schemas gives this really valuable, unambiguous representation of the structural contract between services.
Right, the structural part.
Leads to clearer communication, simplifies development and consumption, acts as that crucial early warning for structural incompatibility.
And you also noted, even if one team owns both client and server, the principles of clarity and preventing structural issues still hold value. That's a really important nuance, yeah. Even within one team, an explicit contract prevents misunderstandings, ensures changes are made thoughtfully, and just fosters better engineering discipline overall. It's about good practice, regardless of team structure.
Okay, this has been really insightful on the benefits. Let's transition to our outro and maybe consolidate some key takeaways, especially for listeners prepping for those senior technical interviews.
Sounds good. So as we've discussed, explicit schemas and microservices offer a powerful set of advantages. Much clearer, more reliable contracts between services.
Which makes development and consumption easier.
Right. And crucially, they play a vital role in early detection of those structural breakages, the changes in data format or shape.
And we really hammered home that distinction between structural and semantic breakages. Schemas are your friend for structural issues like static typing for data interfaces. But for semantic breaks, where the meaning changes but the structure doesn't, testing is still absolutely essential.
Precisely. Schemas define the what, the structure. Testing verifies the how and why, the behavior, the meaning. They're complementary, distinct, but equally important for overall reliability.
So for everyone listening, gearing up for those senior interviews, here's a crucial thought to chew on, something you'd be ready to discuss. Imagine you join a team, you inherit a microservice. It's been running a while, but no explicit schemas.
Uh-oh.
Yeah. Considering everything we've talked about, what's your strategic approach? How do you improve its robustness, its maintainability? What concrete steps would you propose to address that lack of an explicit contract? And how would you weigh the effort versus the benefits?
That's an excellent scenario to think through.
Yeah, it really tests your understanding beyond just definitions, right? Well, how would you apply these principles practically?
Exactly. It forces you to think about trade-offs, about formulating a real-world strategy for improvement. It's not just knowing what schemas are,
but why they matter and how you'd use them strategically to build better systems. Great stuff. Thanks for taking this deep dive with us today.